So again, I'm Andrew Hillier. I'm the CTO of Cirba. And now I'm going to go through how Cirba works. I'll just start with one slide of how generally the analytics work, and then I'll pull up the two different consoles of the product and we'll click around. And we can keep it very interactive, although I'll try to make sure I don't run much longer than a half hour on this so we have time for the last sections, maybe 25 minutes. And forgive me, I'm just going to turn around and sit down while I... You are forgiven. Pull up the product. Actually, you know what? I'm going to stand for one slide, then I'll pull it up. So first, I'll just do the one slide on how it works. So now we're going a level deeper into the analytics. And we could talk all day on this, so I'll just keep it at a high level. We start by taking the infrastructure and doing a very in-depth analysis of various aspects of the data that we get from that. So we look at technical considerations, business considerations, utilization patterns, and we basically do a big cross-correlation analysis. And again, I won't get the details, but we'll take a set of VMs and a set of servers and say, how do these combine? What combinations are good or bad? From a technical perspective, certain things might go nicely together, certain ones might not. Business-wise, I can't put traders and researchers together. That combination will break a PCI compliance rule. So we have rules that are more business-oriented. And then the utilization is really like Tetris. It's like saying I have this pattern for CPU, memory, overcommit, active memory, very, very in-depth analysis of all the factors. And we pull them all together into a three-dimensional structure. So when I talk about this completeness of world model, this is directly at the heart of that. And basically, I might have a cube that has some technical considerations, some business, and then CPU, memory, I/O rates, and each of them makes a wafer in this cube. And what we do is we do permutations in 3 dimensions on the structure. So we'll say, what if I put this combination of VMs together on this target? And it might be that, yeah, it'll work technically, but you'll break a business rule. Or it's all okay, but you're going to run out of memory. Or you're violating an overcommit ratio. Or you'll throw your I/O out of balance, or whatever that is. So it does permutations on this based on the policies. And again, that's where I can say, this environment is a critical production environment. So when you make decisions, don't run things beyond certain levels, maintain PCI compliance, keep 2 servers of spare capacity for HA. That's all part of the policy. So it will come up with one answer. If I turn the knobs, I can turn this into a dev test environment and say, don't hold back capacity for failure, run it up to 95% memory utilization, whatever that is, and the environment will behave differently. So that's why we use the word software-defined infrastructure control. It's not really bandwagon jumping. It's saying that by tuning this, we can control how an environment behaves. The same hardware with the same hypervisor will act differently depending on what policy you point at it. And that's key. And I'll pull up some policies in the demo and show you what they look like. So that engine sits underneath everything we do. Now, one part of the analysis that we use that for is what we call control analysis. And that's the playing Tetris analogy I was talking about. So that's lower level. I've got hosts and VMs in clusters, in these groupings. How do I optimize the placements of the VMs and rebalance them and again, play Tetris with that workload? There's an engine that does that. You can visualize it, so I'll show you this console. You can see it in a visualization. We call the control console. But you don't have to use that because it also just generates actions into the infrastructure. And that's what we talked about orchestration. So it can happily run without you ever bringing up the user interface. You bring the user interface to tune policies and things like that, but not on a daily basis. There's another component that's the routing and reservation system. And what this does is it talks to all these control environments and understands how much resources they have, what kind of resources are they. If you're running a production policy, that's important for me to know. I know that you have N+1 HA, so that might cause me to decide to put certain workloads in you or not. So it understands the capabilities and all the resources, the compute, memory, storage, and it maps it out to an API. It's a web services API. So you can ask it where to put stuff, effectively. We have a UI that I will also demo, which is 100% a client of that API. So if you're wondering what the API looks like, this UI, everything I'm doing in it is done through the API. We can forward details of what it looks like under the covers if you want to see that. That's also where things like OpenStack, Nova Scheduler calls into there. The integration with VRO happens into that API. And those systems will say, Cirba, somebody's trying to start an app with 10 VMs, and one of them needs a C drive and a D drive of this type, and blah, 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 and this, these licensing. And that will analyze that and make a decision on which major environment to put it in. And it's cross-platform. So it could be IBM Power or Hyper-V or VMware or KVM, doesn't matter. And it will then do that high-level routing. And part of the high-level routing is playing Tetris at the lower level. So this is important. So when we're routing something in, we're actually making sure there's space for that exact app in that environment. We're not just saying, well, based on averages, you'll fit. We're saying, yep, you will actually, I have a place for you to fit based on your shape and size in that environment. And it will actually lock the capacity for that because it'll actually put fake Tetris blocks in the environment to say, hold on to this. I have an app coming in 4 weeks from now. and has this crazy I/O pattern. So whatever you do, don't do something that will mean this thing doesn't have its I/O. You can also reanalyze apps that are already running in an environment. And we talked about things like bursting, which is kind of, again, quite early. We don't see anybody just dynamically bursting, but I can reassess anything running and say, is there a better place to put it? And we see that becoming more and more important. That's a backbone of SDN analysis I'll talk about towards the end.
So I have a question there again.
Yep.
So I'm deploying a new application. Most of the time, when you ask the dev team, how many resources do you require? They say oodles. As much as I can get, please.
Absolutely.
It's going to work faster, stronger, be brilliant. And so you give it, obviously, an amount of reservations for those particular resources. How do you take that into account in your policy engine?
So the inbound demands can be very precise or very imprecise, and I'll be clear. So if it's a enterprise app deployment, it might have all kinds of metadata, the SAP project code, all these types of things, and
yes.
It's very precise. And we ran it in pre-prod, and we have the curve of it. For other ones, we might say, I have no idea.
Yep.
Assume it's 100% busy till I see it run for a week. So the control console will auto-correct it. So the beauty is, if I come in with a very imprecise demand requirement,
yep.
We'll say, fine, we're just going to put you there, and almost leave you in a little bubble. And then once we've seen enough data, we'll say, yeah, we can reclaim. You don't need 4 CPUs, because you're absolutely right. You can see in our visualization, internal clouds versus internal virtual environments, purely from where the dots are, because everybody has huge VMs in the internal clouds. Everybody asks for giant VMs. So,
yep.
So we can analyze that and auto-correct it. If you want to auto-correct it, we see some people not wanting to resize people's VMs. Maybe they're paying for that space, and I don't care. But we can analyze that at the lower level. So we can model uncertainty inbound, and then we can correct it later on, or at least tell you how far off you are. And reclaim reports, we have these enterprise reclaim reports that are broken down by line of business that a lot of our customers use to say, did you know that you have 2,000 more virtual CPUs than you're actually using, and this many petabytes of data, and can you give some of it back, please? So reclaim becomes a big topic, but it's tricky from a process perspective.
So when you talk about a reclaim, how do you govern the reclaim though? Do you say over this period of time, the CPU usage is 1% over 30 days, but ignore backups which are occurring between midnight and 4 a.m.? Just talk to us a bit more about that.
Well, there's a pattern later on that will let me talk exactly to that, that's exactly what we do. We'll build a model back through time of the workload patterns, and we'll say, based on 24 hours a day, here's exactly the pattern, and then you can tune to say, I want to go for within the hourly patterns, what percentile data, and say, okay, if that's not above a certain level, this thing, I'm going to reclaim capacity from it. Okay. And which is different than Deadwood, which is also a special case of that, saying this thing's not doing anything. Mm-hmm. So we can tune that, and that's exactly, again, I have an example showing exactly that of a reclaim analysis, where it's important to get the patterns, right? Because you can't just say, on average, it's 1% if it peaks at 9:30 in the morning for 10 minutes at 100%. You can't start taking CPUs away from that. So you have to actually look at the patterns of activity.
And that's the challenge there. The challenge is most customers don't know what they don't know until you tell them.
Right.
So you ask them the question, they'll don't know. Just does it.
Yeah. Well, we did it, again, the slide I have, I'll talk about the process a bit. We kind of there was another product giving recommendations, and they weren't the same as what we were giving, and we kind of spot checked it and got some very interesting findings under the covers, because one was just using 90th percentile data, and we were looking at the patterns, the hourly patterns back through time for the last 4 months, and saying, yeah, no, you really don't want to take a CPU away from that thing. If you look at what it's actually doing, on Sunday it's lit up for 5 hours.
Yeah.
It's so it's all in the detail, and even just the basics like reclaim or bump up. If you get them wrong, it's disastrous, right? So there's actually an example later on that I'll make sure we have time to get to.
So the data.
How do you?
So the data analysis happens once a day in your environment, then, right? So I can understand how that would work in a private cloud environment, but on your roadmap, I saw stuff like maybe about AWS and true public cloud.
Yep.
How do you feel that model would need to change to better support stuff like noisy neighbors in public clouds? I feel like that there's a disconnect with the I'm going to check it once every day model in the public cloud, because people are provisioning all kinds of random workloads, whereas private cloud seems to be something more controlled within an organization. How do you address that with the platform?
Well, so I think we're careful to draw the line that we're not a monitoring tool. And again, so even in on-prem, we find that there's monitoring and there's something happening in the middle of the day that needs to be responded to, like DRS might move a workload, and that's not something that we're going to look for. So we will basically anticipate the model of what the anticipated loads are and say, here's the best known plan based on these patterns, And if we saw data coming in that there are issues, we will correct for that to make sure it's the best possible. If something comes up midday, that's where, again, something like a DRS would have to kick in and do that. And then in our next run, we would see the net of that and say, okay, well, now we're going to have a different plan to work around that. So we just don't see ourselves as kind of that almost the monitoring thing, saying something's going off the rails at this point in time. We do real-time checks in what we do. So we do the analysis model, but for example, when we're doing routing and stuff like that, we do further checks. So it's not just as of midnight's data. There's more going on. But we're not the thing that's going to say, yeah, at 2:30 p.m. This workload all of a sudden happened, and you need to respond to that. That would be vCenter for monitoring, or some of the monitoring tools, right?
So I guess I'm sorry. I guess another question follow on to that is, how do you adjust the cost of the bursty nature of cloud? So noisy neighbor. What would have been great 3 months ago for a platform that we thought was static is not so great anymore.
Right. So that's part of it. So part of it is the routing, and part of it is the tracking of what's running in there, and saying, no, that's your plan has changed. Everything from, so for example, it's reclaim is a big thing in public cloud, because you're paying internally. If you reclaim, you're getting back virtual resources, which may not translate to any physical resources. But in public cloud, your cost model goes down drastically if you reclaim. And I have an example of that.
So I guess even beyond cost model, so it becomes a quality of service question or level of service. If I compare it to networking and I get a burstable link, I can do up to 100 meg, but most of the time I get 20 meg.
Right.
So is that something that we can factor in as part of the analysis to say that, sometimes you can get the equivalent of 3 virtual on-premises CPUs in the cloud, but you're guaranteed 2.
Right.
There's a cost associated to,
like a turbo button type of thing.
Yeah, like a turbo button type of thing.
So I think that can be modeled. There's probably a bit of work to do it for the public cloud modeling. We have other work to do in that area, but it's also analogous to, for example, we model UCS, where the backplane can have some kind of more dynamic aspects. Where what the I/O. So we have some kind of converged I/O types that will kind of model that to say, okay, it's not just strictly that. It's kind of it's a more of an aggregate type of thing. So it's possible to model all these things, but I won't overstate. I'm sure there's some work to do the scenario you're describing.
How do you recognize a VM? So you have a VM running in VMware, then your engine decides, well, it's better running in Amazon. So we do the trick, we move it to Amazon. How do I, again, patch the history onto the new VM in Amazon?
So we can reconcile the models and say that this thing has a long history, and typically what you would not do is you would not do in percentages. We can also normalize to a benchmark as well, because if you're going between the similar platforms, we want to say, well, that's the amount of work it was doing.
Yeah.
If the percentage is meaningless at that point. So there's ways you can link that back and forth. But I don't want to overstate that the hybrid's still something that we're working on. So when I said it's kind of roadmap, so a lot of the data collection details we're still working on right now. Like, for example, CloudWatch versus, how do we get memory data off them? We're doing some R&D around that. So there's still things, I don't want to get too much detail on.
Because, so you're saying you don't have all the data. For example, VMware delivers you more data to build your decision upon than other products do.
Yes, they're all different, and we usually have to backfill with some of them. And like Hyper-V memory looks different than VMware memory, and Amazon doesn't give memory.
Yeah.
CloudWatch.
All data you pull is from Hyper-V vCenter database, or do you talk with the VM directly?
So there's a couple of different modes. Like, for example, OpenStack is the example, where KVM, we can talk libvirt to the host, and we talk Ceilometer. So there's usually multiple options.
Okay.
So that's a good point for bare metal workloads. Are you working through like a Ceilometer, or can you talk to the bare metal host itself?
We can talk to them. So we have agents and agentless ways of talking to that. So we have extensive data collection. We can talk to IBM Power Frames. We can talk to the HMCs, the LPARs, the VIO servers, build an aggregate model.
So now you mentioned the term LPAR, so you opened yourself up.
What's that?
You mentioned the term LPAR, so you opened yourself up. And I also talk to MPARs, VPARs, and LPARs. When I'm talking like HP, like a HP Superdome X, can I talk to that hardware and optimize at that hardware level, or is it just at the OS level?
No, so I will say, no, we don't do those other things. We focus a lot on power, because we see a lot of it out there, and we do a lot of work with IBM.
Okay.
We cover Solaris as well, but mostly is to get off it, kind of thing. And then we don't do much in the HPUX space. So,
no, not just HPUX. So I'm talking about like Superdome X, so specifically the the Superdome, but for x86.
Oh, okay.
The platform itself, but that you answered the
Yeah,
question.
we don't tend to focus on that. Yeah, frankly, the lion's share is VMware, and then of course OpenStack is huge, and Hyper-V is something we also do because we see a decent amount of it, but I think that's becoming reserved.
I know we keep
Another
edging-
question
Yeah.
from Twitter. How often do you collect the data? It's ongoing, I think. Yes.
So we typically do a collection once a day of the data. The data is very granular that we collect, though. So when we go and get the
Sorry?
data, we usually
Once
get
a
it
day.
once a day.
Yes.
Very granular.
But it's very granular data that we get from the
How granular?
history. Well, again, we get 5-minute averages from vCenter, for example. We can get higher resolution if the source provides it. And that's how we build out our models of the workload. So we'll have a full day model of the workload, but we tend to just get it once a day from the infrastructure. Again,
know
with
we-
the caveat, there's some real-time checks that we do when we're making certain decisions, but we tend to go and get all the data at the end of the day.
I know it's my fault as well, and we keep badgering you with questions, but I think you were going to go on to the demo, and then I think a lot of the things because it does a huge amount and is very complicated, and it'd be very nice to see how that huge amount is abstracted away. And so if you want to go to the demo, that would be...
Okay, yep, no, I think we've got about 55 minutes left, so I'll do the demo. I won't spend too long in it, and then we'll cover some other stuff and wing it through the rest of the material.
Zip it.
But these are good questions, so I think hopefully
He should have came with a less interesting product.
That's the challenge. It's too interesting.
Yeah, too interesting. Yeah.
And again, I just want to address, because people ask detail, and part of the reason I showed the robotic control slide is because people talk about complexity. And I say, the thing is that to make the proper decision in one of these environments, it requires a certain amount of depth of analytics. So we like to think that we're not introducing complexity, we're just modeling the complexity that you're trying to deal with.
Yeah.
And we actually abstract it out where possible. So what ends up happening is, we will actually, because you can just codify it in the policies, all this complexity it happens under the covers. The time of day patterns, the policies, that stuff just becomes codified in the product, and then you put a bow on it and you just look at the answers it's giving. So I think the net is that it's not, on an operational basis, it actually simplifies quite a few things because you've actually said you said how to deal with all this complexity. Again, all these questions around historical data are exactly the kind of thing that you need to get right, but then you need to, you don't have to worry about that on a daily basis.
So as you're going into your demo now, I've got a question about access to the portal. That's quite important. You've got lots of rich data here, which I would say not most people should have to see every single part of the environment which you're monitoring. How do you govern access to your system?
So there's very extensive access control around this stuff. So certain groups can only see certain endpoints or certain analytics results, or not even like, for example, this console, you would never give this to an end user because I can see VMs from multiple business groups in this.
Yeah.
And then this user I'm logged in as, I'm in as admin, but I'm still not allowed to change a policy in here. So there's quite extensive access control. And we also have a reporting database. So all the analytics results just get put in a relational database that you can mine however you want. So you can go and a lot of our customers will go and point Tableau at it or something and say, I want to just pull this out and start looking at results.
So is that is it local authentication? Is it Active Directory integrated? What do you?
There's AD integrations kind of thing. I think the main one that we use.
Yeah, cool.
I think there are others as well. We might have done a Tivoli integration as well.
Thank you.
All right, so let's go through the product. We've got 50 minutes. I'm going to be I'll be a little bit mercenary around timing here, but I think we've talked about a lot of things already. So hopefully that accelerates things. What you're looking at is the control console. This is the piece that you point at the infrastructure that looks at all of the VMs and hosts and clusters and stuff like that and tells you how to optimize it, what you need to do, and does the forecasting, which I'll get to. So across the top, you can see different environments. There's some OpenStack, some Power VM, some Hyper-V. The beauty is they all look the same. I'll tell you how to read this in a second, but they're all normalized into the same model. So they're all under one umbrella. So I've got a model of all of these hosting technologies in one place. This environment is a VMware environment. And I'll explain to you these three tiers. There's a fourth tier where model storage we'll show you in a minute. The top tier are the clusters. They could also be VLANs. These are the aggregate groups of infrastructure that the VMs run on. The squares are the physical servers, in this case ESX hosts, and the circles are the VMs. And they're color coded. So this general apps cluster has these VMs, or these hosts and these VMs. And we're basically analyzing everything I talked about and drawing it on a spectrum of whether you have risk, the red zone, meaning that I've got either components that are starved for resources, or I've got imbalances, I've got risks, things that need more resources, or have too much workload on them. Yellow is the opportunity. That means I've got things that are underutilized. It's the waste or the opportunity. Back to the internal cloud thing earlier, you'll see a lot of dots in the middle of this yellow zone if there's a self-service portal, because everybody asks for big VMs. So we're saying all those VMs are way oversized, is the way you would read this. And the green is within the optimal policy boundaries within codification. And the center line is the perfect alignment of supply and demand. So the way you read this is that I've got excess resources overall. The distance from the center is the excess. But I have imbalances and operational and misallocations that are causing things to go into the red at the bottom level. And let's make our way down and talk about how we get to that answer. So in this environment, this general apps environment, I have 10 physical servers. If I play Tetris based on policy, I can fit all the work on 7 of them. That's kind of that Tetris analogy in action. And that's meeting all our policies n+1. For example, this one below it has an n+1 policy enabled. So we need 4 for the work, 1 for failure, and so there's 2 extra. Now, we're not saying we're going to compress it down. You can compress it down. What we're saying is that we're going to balance across all those, but we want to use that to know that you've got a lot of space here you can use up with other work, right? But it's not so simple because I can't do it until I fix these problems. Let me go into policy for a minute here, and I know we can probably spend an hour in this given the discussion, so I'm just going to be fairly quick here. This is running a production IT variant of a policy. We ship 6 out of the box. You can branch them and tune them and that type of stuff, but these have the starting points. And it models all kinds of different areas of operation, and I'm hoping you can see this okay. So let's start with the simple stuff. In this environment, I don't want my VMs to go above or below certain utilization boundaries. I don't want the sustained CPU to be above 70, otherwise I might give it more resources, or active memory above 50. Again, you can do IOPS and percentages or absolute values. So this is what makes a healthy, happy guest by default. The policies can also be over at the app level or the VM level. So I might say that thing, don't ever make it bigger or don't ever make it smaller, or it's a batch job, it's allowed to run 100%, that type of stuff. So that's kind of the speeds and feeds at the guest level. We do it at the host level as well. So these are all the tuning parameters for the host in this environment. So I don't want my memory to go above 90% of the physical memory of the host. If so, then I'm going to rebalance VMs. And we operate against all these criteria and all of them simultaneously. So that cube, when it solves it, is going to come up with an answer that optimizes all of these things, not just one at a time. And it's going to try and achieve balance across the physical server based on this.
Can you nest policies? So for example, your production cluster will have exactly these kind of things which look really good, but you know that within that you have a particular application that has some further requirements.
Yes.
So
yes.
that would nest within this.
But it's not the full policy, and this is where I use a swimming pool analogy. If I'm putting you in the same swimming pool, you can't have your own water temperature. You get the same temperature as everybody else and the same level, but I can give you your own swim lane. So that's a very good analogy for a virtual environment. So yes, you can override for an app and say the allocation policy can be wildly different, but the overcommit can't, because it's not a function of any individual VM. It's a function of the overall environment. You see what I'm saying?
So an individual app, for example, in that kind of thing, you say you wouldn't want to go above 60% CPU utilization example for that app, but then in the cluster you're fine to have 70%.
Right, exactly. Okay. That's a mission critical app, and you faster to give it more resources and never take them away, or VIO servers in a power environment have completely different policies because you don't do that. So speeds and feeds, overcommit ratios. This is running 6-to-1 on CPU and 1.5-to-1 on memory. And again, that's not the out of the box setting, by the way. It's a bit high for this policy, but it's just been tuned in this demo. I won't get into all these things. These are the things that describe how I treat history. Do I go back 3 quarters or whatever it is, and all that kind of stuff. I'm not going to get into details. HA, do I keep spare capacity? Do I use it or keep it empty? And then we're getting into things like, what about security and compliance rules, business separation rules, and these are all examples. You can customize these rules. I want to keep different departments from touching each other, or I want to keep my IIS load balancers from spread apart as much as possible, or concentrated as much as possible. So you can get quite granular with the way this is. So I might have a policy saying, for this environment, I push apart load balancers, I keep 1 server spare for HA, I enforce PCI compliance, and I'm going to call this my silver tier, or that's going to provide this environment with a certain set of hosting capabilities that it maps out to the world, as opposed to another one which might have, more mission critical settings.
What elements of PCI compliance are you enforcing?
So it's basically the way we do it is it in? I'm not sure if it's in this list. No, I don't think it's in this default one. There is a rule that you can enable. Basically, it's based on the tagging of the VM. So we would need a feed from a CMDB or whatever to describe because we would get it from Virtual Center, for example. saying what, the various aspects. Most of our customers will do this thing as prod or non-prod or belong to this group. And then this will just enforce separation rules on that so they're not touching each other in the operating environment. I think is what the base level rule does.
So in terms of your policies, just for a moment, obviously they're quite complex. They require some tuning there. For your typical user installation, how much time do you have to do on-premises training with a customer to say, look guys, this is what all the policies mean, and how much time do you actually then spend supporting customers ongoing around your policy engine?
So usually it's not a widespread thing in the customer. Usually there would be a handful of people that would be the ones that know and do this, and it's not we basically have a very extensive guide saying what they all mean, but in reality, there's only a handful of them you typically tune to get started. The IO levels, overcommit levels, stuff like that. So you usually go with the starting point and go very quickly. So I'm not sure exactly how long the training is. It's several hours to kind of go through and describe all this stuff, but it's not as onerous. There's a lot of detail in here, but again, you don't necessarily tune all these things. Most of them out of the box. Most of these things out of the box are far beyond what anybody has already in their environment anyway. So it's not a big deal. There's usually 2 or 3 people probably that know the policies, and once they're locked down, nobody really changes them. So we're working with one customer now where they basically there was sessions done on that. I think there's several sessions to tune the policies for I think there's 3 different policies in force, and then they got locked down. That was it.
But I must say, good job on just the simple English to even look at those policies, because with lots of nerd knobs that can be changed, half the issue is even understanding what the title is. So,
Yes.
Yep.
So that's
Even talking about nerd knobs, is this a 80-20 type of rule for customers that 80% of the default out of the box stuff is where people find the most value at, and there's only a few customers that really need the, kind of most of the guys in this room need the nerd knobs?
Yeah, it's true. I mean, we have an advanced settings here, which makes more stuff show up. But we talked about putting more of this stuff just into advanced because the truth is, not all of these things, you're absolutely right, are necessarily need to be tuned. There's kind of this middle ground in that. Again, we talk about complexity. We talk to customers, they say, well, do you model X? Do you model Y? Do you this? Do you do that? All these questions. So to get the right answer, you have to model it. But then they look and say, well, then I have to model all that stuff. It's kind of a double-edged sword. We had one customer kind of getting this big argument with themselves over this, and they realized, well, we have to do it. We can't not have that third line down because then it's not right. So that's kind of, but the idea here is that what you do is you tune this, and then you just close it up and say, okay, that's been set. A lot of our customers now, you're not changing that unless there's a very good reason why, or we're going to tune it. And usually there's 3 or 4 policies that are in force.
So one more question as well. In terms of the software itself, is it customer installable, or do you say you've got to buy so many days professional services from Cirba basically to install it?
No, the customer can install it and run it. Yeah, There's certain things again like this stuff we just want to make sure that there's a lot of also self-guided training that's available. So yeah, so some people are remarkably proficient at just getting it all working. But again, I go back to that completeness of world model. To do the level of automation we're talking about, a lot of these considerations are important. You can't just gloss over them. And you've asked questions earlier about averages versus peaks. You've got to go into the numbers in more detail if you want to get the right answer. But anyway, let's close up policy now and let's just say what this is talking about. What this is saying. So it's saying that I've got spare resources in this environment. Yet at the same time, I've got hosts in the red. So I've got more than enough capacity, but I have squares that are off in the red here. And if I open that up and look at Y, I can see all of the metrics for this host. So the CPU, active memory curve, I'm just going to go quickly through here. I/O patterns. So what this is a 24-hour view by quartile. So for example, what this is saying is that between noon and 1 p.m., it peaked at about just over 3 million bytes per second, I guess that would be. And that thick red zone is sustained activity. That's the third quartile, meaning it spent at least 15 minutes above that level. So immediately I can see overnight there was kind of a ramping of I/O. It kind of went down, but there was some sporadic activity, and there was a pretty good sustained I/O middle of the day. This is the analogy to the Tetris blocks. This is what we're looking at to say, okay, this gives us a lot of insight into what's happening on this box. And this is at a physical level, so this is actually due to a bunch of VMs, and we're seeing here that there's a resource of policy violation. The CPU on this box is higher than our comfort zone overnight on a sustained level. So you can see it's chugging along, staying at like 80% overnight. So I've got too many VMs that are busy overnight on this physical server. That all make sense? The same one beside it, it's a lesser violation. It's got a bit of a memory infraction and a slight CPU infraction. And the reason why is I have these hosts over here that aren't doing much at all. This one is barely even blipping on the radar for its utilization. So this is a clear case of an imbalance. I need to move VMs between these hosts to balance this out. And we will find very, very complex imbalances. Like the I/O imbalances, active memory usage imbalances. It will sort all these out, and it will do it predictively. So you can tell the policy, that may not have happened yesterday. That may be at high risk of happening if you look at the patterns of what's running on it. So we can actually even say, based on the VMs that are on that host, you've got a high risk of this happening. So we're going to take care of it before it even happens.
So this is where you would work with DRS, because DRS, in effect, should be moving that exact workload. It's CPU or memory bound.
Right.
Overnight, that should be moving that workload around.
So we'll find a whole lot of stuff that DRS won't find across all the other
Yeah, because
types.
if you're doing network I/O or some storage kind of things.
But even in this case, this would probably be a case where that may not have happened yet, but we're just saying there's a likelihood of it happening based on the models.
Okay, so you said that was 24 hours in the past. That's not 24 hours in the future, is it?
This is a predictive model based on the past. So this might go back through 3 months and build an envelope of what the utilization pattern looks like and say, yeah, we're looking like we're at risk.
Okay, so is that looking at a typical day?
It could be a typical day. It could be a blend of a whole bunch of days. It could be a busy day. Yeah, that's part of it.
So when looking at that, that may not actually be happening now as an issue, but in the general lifespan of that particular host, this is what normally happens.
Yes, exactly. You can go back and see actuals too. I'll open the time slider in a minute, but I can actually go back and see what actually happened yesterday and the day before as well.
Okay.
But our today model is a predictive model. Is basically the best way to look at it.
And of all the actual resources that you monitor, which one do you give priority to? Memory, CPU, disk? Which one is it?
Well, so
Winner.
There's not really a winner because we look at them all simultaneously,
Right.
and that's where I think there's other products that might look at one at a time as opposed to all of them. We look at them all simultaneously, and we'll come up with an answer that meets them all simultaneously. If it can't, the dots will go off into the red, but it'll do its best to get as close as it can to that across all resource types, right?
Okay.
So you might not be able to balance your way out of too much memory utilization, but we'll get everything as level as possible in the process.
Question from Twitter, how long do we actually store this data? Like how far back can we go in time?
So it's actually stored in a very concise, compressed format, and we have customers with years of it. You can keep all of it. You don't really need to age it. So I think we have one customer with 5 or 6 years of that data. So they can say in the policy, go back really far, and they can just go in their browser and go back. So that's the beauty of it. We keep that. This is a good resolution to analyze, and it's very concise to store. So we don't roll it up beyond that. Okay, so I'm going to keep trying to go fast because I'm conscious of the time. So I've got imbalances and misallocations of resources. Here's a VM that we might want to give more memory to. Here's a VM that we might want to take some CPUs away from. And that's where, again, earlier in public or private clouds, there'll be a lot of dots in the middle of the yellow zone because everybody asks for a huge VM and nobody uses it. So what we're going to do is generate recommendations to say, take some resources back. It's recommending we move that VM and take 2 of its CPUs away. That's based on policy as well. And overall, we're going to say, do all of these things. Again, I won't dwell on these. Make it bigger, make it smaller. The resizes go to service desk, and the moves go to vCenter. That's part of the policy as well. And we're saying, do this to fix this environment up. And if you do it, you should look like this. So we actually do a predictive analysis of what the environment should look like if you take the actions. So not only are we saying why we're saying take the action, we're saying you should look like this if you do it. And the result here is that you're going to have a much better balance across the physical assets. These dots being together is very good. And I've gotten everything out of the red down here, meaning I've given things more resources to stave off any issues with misallocations. And now I can put more work into this environment until it's full. But I can't do it when it looks like this because this environment is probably already not behaving really well. We find most of our customer environments around 0.5 to 0.7 efficiency is where they kind of stop putting work into them because the problems at the lower level start to make it strain. And if I put more work into it, it's just going to get worse. So I'm just going to stop there. That's the basics of the control console. It's basically analyzing supply and demand from a supply perspective. So a hosting environment, I'm going to balance out these resources. I'm going to resize workloads. And the main thing is I'm going to then say, how much more can I put in these environments now to fill them up once I fix those things?
Or how many hosts can you remove?
Or how many hosts can I remove, which is the other thing you can do. And you can even model that type of stuff in here. I can say, let's remove these and model them out, and you can do all kinds of fancy
So
stuff.
just looking at that owner column, that looked quite interesting. That so, for example, something that it could do in a VMware environment is move it between clusters or move it between hosts. That's fine. But the other integrations, would that be to remove a CPU, may log a call with ServiceNow,
Absolutely.
which would then generate a ticket to an operational team to do X, Y,
Yes.
and Z. So it's not necessarily has to be an automatic thing.
Nope.
It's just raising an alert or even an email, I suppose.
Absolutely,
about
but
something.
even it's automatically raising that, it's more customers say, well, that's a useful automation because I don't
Yeah,
want to.
definitely.
Yeah, so no, those usually go through a change management process for sure.
But you're only working within that one environment at this stage.
So let's segue now to beyond this environment because that's a good option. So that's this environment, and we're doing localized actions. I've got another IBM environment beside it where I've got hosts that are overloaded. And these might be giant frames. Again, same picture. Same with our OpenStack environment. I have some availability zones, KVM hosts, that type of stuff. So the question becomes, let's take it up a notch now. This environment has 4 different places I can put workloads. That's the net of this. So these diamonds at the top are 4 different clusters. Again, this OpenStack environment has 3 different availability zones, each with a certain amount of space and certain capabilities. Right? So we know what they're able to do, what basically their policies are, and how much resources they have. The question becomes, how do I make decisions on where to put workloads across these environments, or if I want to move some of these out, how do I make that decision at the higher level to go to a different environment? And that's where we get to this console. So we're going to shift gears now and go to this other one. I know it's resized kind of small because the screen is, let me see if I can zoom it in a bit and make it a bit bigger.
Can you just talk us through as well? Because am I right in saying that your software looks at software licensing as well?
Yes.
That's a key cornerstone of what you do for me. So can you show us how that comes into your mapping as well when you go through this presentation, please?
Sure. Now, so you can visually see it in the other console. I'll show you a little bit of it here, and then I have a slide that does a better job.
Yeah.
So maybe what I'll do is I'll just plan to cover that slide. Let me just find a zoom level that kind of works here, so you can see everything on the screen. It's just because we're on a smaller projector. Okay, so this is the reservation console. Think of this like hotels.com for IT. So this is now modeling all my global capacity. So down the right, these are all those hosting environments I was just demoing. These are those dots at the top of those control consoles. So I've got New York General Apps, that's one of the ones I was showing, and I can see what it is. It's based on Dell PowerEdge gear. It's got space for 59 more certain size VMs. So now we're looking at it in terms of demand. I've got so many hotel rooms left in this environment, and we can say what a hotel room size is. And it's got certain amenities. So this is where we're saying now, it's like a hotel. Again, does it have a pool? Does it have a business center? Does it allow dogs? We're saying this environment is based on certain hardware. It can run certain operating systems. I can make certain size VMs in it. It's attached to certain tiers of storage. It's licensed for certain software. Again, you can tell it's in a certain location. So not only do I know the detailed resource picture of that, but I also know what it's capable of. Does it have hardware encryption enabled or that type of thing? And it might vary. This top one is a Unix environment. It has very different capabilities. It's licensed for Oracle and makes different, I can make really large LPARs, that type of stuff. So we have a view of our supply, as I was demoing, and how much space it has and what its capabilities are. On the left are inbound demands. And as I mentioned, everything here is available through APIs. So I might not use this UI at all. Most of our customers don't use this UI. I would just inject these through the API and figure out where to put them. But just for for an interactive demo, here's a customer billing system going out. Let's just assume it's a month from now, and it's got 6 VMs and they have certain requirements. So let's just walk through this. This is this demand model I was talking about earlier. The first part is just kind of the basics. What day is it starting? Who asked for it? And what are they asking for? It's a 2x6. Looks like a WAS server from the catalog. So far so good. Somebody's asking for a WebSphere app server. It has 3 drives, and they have different amounts of configured and or used space and different tiering. So now we're starting to get a little more complicated. So I need to find a place for this to go that has enough gold tier 2 and gold tier 1 storage to meet the needs of this VM, and not just this VM, but the other 5 that go with it. Right. So I've got now I'm starting to get into not only allocations of resources. What do I expect it to do? This one we might say, I ran in pre-prod and I already know what it's going to look like, or I have no idea what it's going to look like. Assume it's just a CPU-intensive workload until I see it operate for a while. That was that earlier question. So these could be actual, or they could just be theoretical. If it's coming from OpenStack, we just say assume it's busy until we see it for a while, and then we'll figure it out. Does it have certain software requirements? Does it need a certain license? Does it have certain business requirements, or does it need to be near certain things? Technical requirements. You probably get the idea here. We can do a very detailed model of what that inbound demand needs, and it may be detailed or it may not. Again, if it's coming from an OpenStack request, it'll have very little detail because it'll just be an allocation request basically. But if it's coming from an enterprise risk management process, we might have a lot of detail in here. And this is really that demand pipeline. So a lot of our customers have this kind of data. They just don't have anything they can do with it to map it to the infrastructure. They can open change management, do change management with it, but not actually analyze it. So I've got inbound demands with very specific requirements, and I've got hosting environments with very specific capabilities, right? So that's kind of the two sides of this equation. And I can take this, if I can find this, and I can analyze where should it go in my hosting infrastructure. Let me see if I can hit that and get more space back. There we go. So I can say, where should it go? So I can choose individual components or the whole thing and say, evaluate against all my environments where that can run. And what it's going to do is it's going to rank them at application. And you see there's really only two environments that can run that. I've got New York and Houston. And so the analysis it did was say, well, let's analyze all of the what we call fit for purpose criteria. So these two environments meet all the stated requirements. They have enough of the right tiers of storage and are connected to the right networks and have the right software on them for this to go. And they both have enough space. You'll use about 13% of what's left in New York production and about 15% of what's left in Houston. So that's based on the actual workload of that thing, the compute, the storage, we've got enough space. And so we're going to favor the one that has the most spare capacity. It won't go into this Toronto dev environment because it's for a couple of reasons. It can't run HR workloads, and it doesn't run prod in this case. And it's giving us a detailed view of what the violations are. This VM can't go there because it's a production workload, as an example.
Can we add cost as a driver for this? So, for example, if I know one cluster's more full from resources, however it's cheaper, and from a business perspective, I'd like to leverage that first.
Yep.
Is that possible?
Yep. So I just turned on cost. Let me just I'm not sure if the costs are set up in this demo, but if I turn on cost, I'll get. Oh, sorry, they're not. Okay, as luck would have it, they're not there. They're not set up. Yes, it will do the relative cost ranking as well. So the idea, and that's quite important because the penthouse fits me and a normal hotel room, but I'm not going to take the penthouse if the normal hotel room works. So usually some base cost ranking is useful just for the tiebreakers in there.
And the cost, is that auto-populated? Do you put it out of certain clouds, or is it a manual? I type it in and update an Excel spreadsheet.
So right now you enter it in because, and that's why we call it relative cost, because we talked about that with our customers, and they said, well, we can't get a really accurate TCO of that thing, and we said, well, just model it relatively to get the rankings. And again, that's good. So that's what they do, and part of the hybrid stuff is looking at where we get cost data from those things, and we're having some discussions with, like for example, Gartner just bought a company that does cost metadata analysis of public clouds that we might be able to feed off. So we want to come up with an apples to apples comparison here because, again, the on-prem TCO is quite different than it's going to be fully loaded to be able to compare that. So the answer is yes, cost. Unfortunately, this demo database doesn't have any cost data in it, so it's not showing up. So I'll just turn it back off.
This placement, because this could be, I can think of an example in an enterprise that they're deploying this new finance application, but in 3 months' time.
Yep.
So at the moment it's going to do the recommendation, but in 3 months' time that may be a little bit out to date. Or something may happen that, for example, I could run it in Toronto and the only limitation is a technical requirement on resources. Well, in 3 months' time, I could purchase another blade or purchase another sand shelf or that kind of thing. How is that sort of...
So this is totally predictive. You see, I'm looking forward in time to all timelines. So these dates are in the past because it's a demo database. But just picture if that was a month from now, the analysis will be taking into account all the storage you're adding in the next month or any changes to the environment in the next month.
Okay, so you would say, so I suppose that in advance you could say, well, I'm going to be buying 3 more blades for Toronto,
Yes.
for example, or will this say you're going to need 3 more blades for Toronto in 3 months?
Yes, it will do both. So let's just do this. Let me just route it to New York. I'm just going to say go and send it to the highest scoring environment, which through the API would just happen very quickly and you'd be done. And we even get a little boarding pass saying, here you go, we are guaranteeing you capacity in New York at that future date for this workload. And what it did under the covers, and this is very important to your question, is I didn't show this timeline. I was just showing, everything I showed here was today using historical data. But I can go forward in time, and if I go forward 30 days, I will actually see that app. I'll see apps coming into my environment. So this is where it's a predictive analysis. So we're saying, That was just right now, you need to clean this up. But if I go forward in time, I'll see all kinds of inbound and outbound activity. And I can model in new hosts, I can model in new data stores, I can model them out. And the idea is this is not just a what if, this is a living model of the environment. This is actually what's happening in the environment. So bookings that are more than 1 month out will go if they're asking for storage, if you've added that store, model it in. So it's a completely predictive model of supply and demand. And
can you also have it tell you what to buy?
Yeah, absolutely. So if one of these goes, if I go off further, that one went off in the red, and if I tooltip it, there's other ways to get this, but if I tooltip it, it's saying, I have 7 servers, I need 8. You basically need another server, another blade in that environment to meet the workload demand 60 days from now.
Okay.
Yeah.
Then how would that have originally placed that into New York, but then you need another blade to satisfy that? Because would that have failed?
Yeah, that wouldn't happen if in our routing, that won't happen. We won't route into an environment that'll put it into the red.
Okay.
So key here is what's happening is these things down the left are like fake Tetris blocks, and we're putting them in the model at the future date. So they're there holding the resources. So if I say that it has this I/O pattern, I'm holding that I/O for that app, and no other workloads can come in if they're going to impair my ability to deliver that. So it's just like a hotel. You've got it. You've got the space for it. I can't book someone else in ahead of you if they're going to ruin, if they're going to overlap with you and there's no space. So it's a very, very precise predictive model of the environment.
So it's as precise as how much you know about the future, because if you're going to model something 6 months out, obviously your environment's going to change. You're going to buy 3 more blades, but at your placement doesn't know that. So potentially, actually, Toronto is a far better place to use it when you buy 3 more blades in 6 months' time.
Right. And that's where, so the further you go on the timeline, the more abstract it does become. Like people tend to do more bulk bookings out there. Some of our customers say they want to model 5 quarters out for budgetary purposes, but they're not nearly that precise. They're not going to be individual requests. They're kind of like bulk projections.
And once that booking is then done, can that booking then be revisited and then say, well, actually now, seeing that we've now bought at time of deployment or even a month in advance, go, well, actually now Toronto is a better place to run that because we've now put 3 blades in.
Absolutely.
You want the futures in an options market, effectively.
Yes.
Yeah, so you can
delivering.
You can revisit them at any time. So in this UI, this is the inbound hopper of unrouted requests, which might just be coming from the API and happening automatically. I can click over and look at the other side of this, which is what's been routed into all these environments. And if I just click off that, this is my demand pipeline of what's been routed into the environment. And I can take any one of these and reanalyze it if it hasn't landed yet. If it has landed, I can reanalyze it differently there. But up to the point of the fulfillment, I can reanalyze it and reroute it anywhere else. And
I suppose you want to do this in a really automatic way. You would be running this fairly regularly, and you would expect your future bookings to move around as your physical resources change.
Yeah, they will revisit. And the other key thing about this is that we don't say like a hotel, you don't get your room number when you make the booking. You get it when you show up. So that's what we do. We give you, you're going into this property, and then when you go to fulfill, we give you the actual details of the placement, because we might shuffle things around to make everything fit in the days leading up to when you're coming live, right?
So taking the conversation a little bit less technical, because not all of us are really great with the knobs. I have it's a tower question, because you're selling this into really large organizations. So the target audience kind of rides a couple of different towers. It feels a little bit like an operations tool, but at the same time, it's more of an architecture capacity planning tool. Where do you guys find the most success in having this discussion with customers or potential customers?
It's a good point, because it does span several things, especially when you get into software optimization, which I'll show you in a second, which spans to an entirely different care. So usually it's the infrastructure management teams. I mean, there's a home for us where it is operational, but it's usually kind of the architects and engineers that bring us in as a new thing to plumb into the environment. So ultimately, when it's operating, we interface with groups that are operating it to a certain level. But a big thing for us, for example, is architects that are building a new environment. Then that's usually where they'll say, I need something like this to plumb into it, and then make it operate. So it does span multiple. That's where, again, I think the consoles are interesting because they show certain use cases, but if you picture, for example, for a second that you're not even using the consoles and it's just running under the covers, then it kind of simplifies the discussion, because then it's just taking away underneath the covers. There's certain people that look, we have a console that shows you what actions we took last night, and the data collection and all that status for the operators. And then we have a reporting database for all the people to mine it for the data they want into their portals type thing. So that's where it tends to live.
I'm thinking from my own selfish perspective. I'm on the architect side of it, and I bring it in, and I have this new project, and I know how to architect a solution. And once it's done, I have this really great tool that I no longer need, and I champion. But now we have it, and now it just dies, and
Well, again, so typically what would happen is it'd be handed off into the teams that operationalize it and have the runbook for it and make it run. So that's the case. And back to that earlier thing about the resiliency of our product, that's where it usually hands off and says, okay, now usually a point where we're flipped over, we are production, and then it kind of is a different group that's watching, that's handing it over. It's a dynamic we often see where.
Yeah, because while a good portion of it is automated, there's still a lot of care and feeding that needs to be taken into account. Whenever we enter a manual cost, those costs adjust over time, and if no one's care and feeding the tool in the models, then it can become a stale problem.
Yeah, and typically what we like to do is feed off systems of record. So if there's a CMDB with decent data or whatever, we just want to tie into that. Where
So
we
it's
have
best
from
from a success perspective of being a extended return on value for an extended period of time. Try not to put a lot of manual data in it because
we try.
So for customers from
Yeah, no, you want to kind of plumb it in and have it. And again, we don't necessarily have to be the system of record of a lot of that data. We just want to feed off the things that know what to drive the analytics. That's kind of the best way to think of it.
I might have missed this, but do you take into account your customer's procurement cycle? So, for example, how long it takes them to actually even raise a PO, to buy a blade, to put into their data center, or not? That's kind of a key objective for most people. That can be 30 days, 60 days, 90 days, or even 6 months, depending on the size of the enterprise. And that can have a massive impact on your analysis.
Yeah, so what you're bringing up, we had that discussion. We don't formalize those boundaries, but what we talk about here is, for example, and you can configure this to have the next 7 days as well, right? Or where there's a period of time within which you can't make certain types of changes at all. You're not going to buy any hardware, but you can move VMs. And then a little further out, I can actually move hardware I have or deal with hardware I have, and then there's the procurement. So the 90-day out would kind of be like you're saying, like within that time frame, I can actually get more on the floor. Anything earlier than that, maybe I can't that fast. But we don't formalize those boundaries. That's the way and the 5 quarters is the budgetary one, right? So it's kind of budgetary, procurement, and then use what you got.
So a minimum has to be, if I'm reaching capacity, my procurement cycle to add more capacity has got to be a key metric to be included in your solution. Because if I don't add more capacity in that 90-day period, then I know that I'm going to have some constraints that are going to happen in my environment.
Yeah. So basically, if you see red out in the 90-day time frame, again, that can be dealt with. If you see red in the 30-day time frame, that's a completely different ball. You really want to avoid that, of course. So again, we don't formalize what those boundaries are, but that's really the kind of the intention of the timeline and the output that we give is to line up with that kind of thing.
But it becomes a great tool to give the business to say, hey, look, in 90 days you're going to have a serious problem if we don't prioritize this purchase or this PO process, then it's going to have an impact to the business.
You are right there. However, though, I'm just concerned that the people actually looking at this portal might not know what they don't know about how long it takes to get a new piece of kit into their environment, and therefore you're running at risk.
And I think that goes to the tower conversation of who buys the product, who controls and who looks at the data, and that person can have a complete disconnect, especially in large organizations, between what it takes to actually.
Absolutely.
If the architecture team is looking at it and the operations team is the one that has to go out and buy the hardware.
Yeah.
It takes some coordination.
At least you have visibility.
Yeah, you have at least. It's better than not knowing.
Because a lot of places don't. Oh, we're running out of resources.
Don't know where and why.
Yeah. And just to close out, the last thing we showed in the demo is highly related to that. If we pull up the 4th tier, that's where we also model physical storage, logical data stores. So I can see the data store linkages to the things, to the components. And sorry, I'll just go back in time. And they draw down as well. So we'll route to the data stores with the most space. You see these ones at the bottom right. And fill up those resources as well. So a lot of times we see a lot of fragmentation or stranded capacity where you're out of storage in that environment, there's lots of compute, or vice versa. So that's all part of the model as well. So that's all part of the decision. So we're going to level off the use of data stores, bearing in mind what tiers of storage they provide, across all the environments over time with the compute. So it's like playing Tetris at a global level. We're going to route workloads into environments in a way that makes use of the resources that are available in that environment. So it's
how deep can you see into each environment? For example, in VMware, I can put tags on data stores to show that it's replicated, not replicated, to show that it
So
has...
I'm actually not sure how deep we go into the tags on that. We do model the service levels of the data stores and the mappings to the physical storage. So one of the things we just announced was we have NetApp OCI integration, and we just released EMC SRM integration. So we can see the physical storage underpinning the data stores, and we can see its attributes as well and map that back up through.
So you talk about actual physical storage and the attributes there. You look at the HBAs and the queue depth of HBAs as well in terms of your quality of service moving forward.
There's a certain amount of it in there. Again, I don't want to overstate what we do. We don't rebalance across the controllers right now, but we will basically look at the physical storage and whether we look at the I/O rates on that type of stuff. But again, since the pathing might be complicated, it's not. We're not a virtual instruments in that regard, I guess.
So you're saying you're looking at the hardware, for example, in storage, you're looking at the hardware level, but it could well be that at the VMware level, I combined a set of data stores to present as silver, although on storage they may look like better quality.
Yeah, so we will take the service level from the data stores that they're mapping out, but we'll verify that there's enough underlying physical storage to fulfill on the data stores. Or vice versa. So basically, when we route something in, we'll make sure there's enough data store space of the right tier and enough physical storage underpinning it to do the routing request to make it land.
And you also won't get into a fight with storage DRS, for example.
No, so we don't get into that. We don't get into moving the DRS. Yeah.